what do we have here? If you look example 2, we get this x minus 3 is a quotient. Is the degree of r less than the degree of a has degree less than the degree of b. So yeah, 8 over x plus 3, there we go, yeah. The degree of the numerator is less. Degree 0, denominator degree 1. Is it reduced? Yes, it is reduced. And so this right here is what we call the divided form. And then now let's look at the quotient here, q of x. Well, this guy has a vertical asymptote too. X was negative 3. And then, what is the horizontal asymptote? No. In this case, q of x is what? Q of x is linear. If q of x is linear, what do we get? We get a slant asymptote, or we call an oblique asymptote. So this guy has two asymptotes. X equals what? What are the asymptotes here? What are the asymptotes?
One of them is negative 3.
Asymptotes, what? What are the asymptotes?
X equals negative 3.
That's right. X equals negative 3 is a vertical asymptote. But what else is an asymptote?
I think y equals negative 3 if you plug in 0 for x.
Y is equal to what? Y is equal to what is the asymptote?
Negative 3.
Y equals negative 3 is not an asymptote. Y equals negative 3 is not an asymptote. Now let's look at the language here. Let's look at the language. It says this is x minus 3. So we have two asymptotes. What are the two asymptotes? The two asymptotes are x equals negative 3 and y equals x minus 3. So I want you to understand this language once again. So we look at the language here. Look at this. It says here, if c is a number which makes b of c equal to 0, then what is an asymptote? X equals c is an asymptote. Now we look at, and then now, how about this q of x? Q of x, if q of x is linear, in this case, q of x is actually linear. Look at this. X minus 3 is linear. If q of x is linear, what is an asymptote? Asymptote is y is equal to q of x, not q of x. Is that clear? So here, let me say this. Not negative 3, and not x minus 3. There is no line called x minus 3. Is that clear? There is no line called x minus 3. So you may say, well, when you say x minus 3, does not automatically mean y equals x minus 3? Now let me ask you this. Does x minus 3 mean y equals x minus 3? What do you think? Do you think x minus 3 is the same thing as y equals x minus 3? I think some of you may think so, but no, the answer is no. X minus 3 is not y equals x minus 3. So don't make a mistake here. It's not automatically, no, it's not true. Okay, so x minus 3 is an expression, whereas y equals x minus 3 is an equation. Their structure mathematically is different. X minus 3 does not mean y equals x minus 3. So don't make a mistake here. So there is no line called x minus 3. By the way, the asymptotes are lines. Asymptotes are lines. And therefore, the asymptotes must be line equations. So negative 3 is not a line. X minus 3 is not a line. If you give me any of those, then you get a 0 right away. Okay? So don't tell me, oh, that's too much penalty. Well, it's wrong. Okay? So please, I'm saying this one more time. Asymptotes of graphs of rational functions, please study them. And also study the definition of asymptotes. These guys here, make sure you study them too. So make sure that you study these guys right here. So study this asymptotes, definition, asymptotes, study them. And then make sure you study these guys too, all right? Any questions here? So a lot of them. Okay, study, and then make sure you understand and make sure that you can apply. Now, on example 1, I might ask you like this. I can ask you this. Let's say in this case, instead of writing this, I can ask you, show that this graph has asymptote x equals 1. If I to show, now if I use the word show, then now what comes in? If I ask to show, then what do? Show, that means what? Must use definition to show that, must use definition. The show means what? Prove by definition. Prove according to the definition. In this case, the definition of asymptote. If I ask you to show something, what does it mean? You have to show that there's an asymptote x equals 1 according to the definition. So now we go back to definition. Definition of vertical asymptote. This is a vertical asymptote. The vertical asymptote, what is that you have to show? Well, the vertical asymptote is this guy right here. So y equals fx has a vertical asymptote x equals c. So in our case, x equals 1. So we're trying to show that x equals 1 is an asymptote. If x equals 1 is an asymptote, then what is it that we have to show? We have to show this guy right here. This guy is a c plus or minus. That means we just have to show one of them. We don't have to show many. So what do you have to show? You have to show this. You have to show, what is it you have to show? You have to show that the limit of what? The limit of, you know, this function, the limit of function f of x. F of x is this rational function right here, and this must be what? This must be either plus or minus infinity. So the x approaching 1. In this case, why don't you just do x approaching 1 plus? Just do up to 1 plus here. One of them must be true. And then you have to show that blah, 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 blah. And this guy must be eventually will turn out to be infinity right here. And don't just write this equation. Don't just write the statement. You have to show. Show means use the definition. Anybody? You know what? These kind of questions is a high target now. It's high target. Okay? I am geared. I am. You know what? If you go to if you go to all these websites, you can take the derivative and all graphing everything. Again, I will be testing you, especially on things which your graphing calculator cannot help you. Okay? And so the emphasis will be on logic. Make sure that you study everything you need to know. Don't depend on graphs. Again, my emphasis will be on problems which cannot be solved by graphs or graphing calculators or by mechanical taking the derivative. Yeah, there are all kinds of websites out there who will take the derivative for you, right? Yeah. In case you don't know, maybe I can show you one. Does everybody know a website where they will calculate all the derivatives for you? Does everybody know or not? And I'm sure many of you already know, and that is not a secret. I know that. Okay. So again, the emphasis will be on problems which cannot help you with a derivative. Okay. All right. So let me save and then clear. All right. And then all this here and all that. Now let's look at example 5. Example 5. Example y equals x squared minus 2x over x minus 2. So when you divide, this is what we get. When you divide this, you get this. And then note that the denominator becomes 0. And then becomes x. But this is when x is not 2. So does it have an asymptote? X equals 2 is an asymptote or not? Asymptote? X equals 2? What do you think? You think we have an asymptote x equals 2? Because you see this x minus 2 here in the denominator? No. In fact, this is a line. This is a line. This is a line with a hole. With a hole. With a hole at x equals what? X equals 2. That is at the point 2 comma 2. Okay. This is a line. This is a line. Line x. Actually, this is a line at y equals x. This is a line y. This is a line y equals x with a hole at x equals 2 or 2, 2. This is what we call a punch hole. Yeah, we call this guy punch hole. Okay, all right. By the way, this example 6 here. This example 6 is a definition 3 prime. According to asymptotes definition 3 prime. After 3 prime, this is the last guy, because this guy to the q of x is not really a polynomial. And note that if you look at this guy right here, this guy is not a polynomial either. But what we do know is that this guy will actually approach 0 as what? As x is approaching infinity. As x approaching infinity. So as x approaching infinity, this guy is actually approaching 0. So now in this case, what happens here? This guy, this function right here, this graph is what? This graph is asymptotic to, and the y is equal to, and then x. Oops, what happens here? Y is equal to, let me write, y is equal to square root of x. Just erase this x right there. So this is the word we now use the term asymptotic. Again, study the definitions. Study the definitions correctly. Study definition of asymptotes. Make sure that you understand what they're saying. Okay? Study definition of asymptotes. Okay? Then I might ask you, show that this graph is asymptotic to y equals square root of x. If I ask you that question, again, if I ask you with a verb show or prove or verify, so whenever I say show or what? Prove or verify, all of these things, what does it mean? All means what? Proof by definition. But proof according to the definition. Okay? You have to use the definition. So these are the most common verbs we use in math. Show, prove, verify. And there might be some other commanding words too, but I cannot think of at this point. But you know what, and then there might be some other words here, but make sure that you understand these guys. Okay? Now, let's look at this here. Let's look at this. Let me see it. Save and then clear. Now, let's see example 7 here. Example 7. Oh, yeah, example 7 is a little bit tricky. Example 7, y is equal to 3x plus 8 over square root of x squared plus 1. Do you have a vertical asymptotes? Example 7 here, does this have any vertical asymptotes? Now, once again, in order to have a vertical asymptote, what must happen is the whole thing must go to plus or minus infinity. That means the denominator must approach 0. So the denominator becomes 0 at any point. Numerator must approach infinity. So in order to have a vertical asymptote, you can look at the definition of asymptote. The numerator must approach infinity. So what that means is, the denominator 4 must approach what? Must approach either 0, or plus, or minus. It must approach 0 plus or 0 minus. But in this case, if you look at the denominator, is there a chance that the denominator will actually approach 0? No. the denominator cannot be 0 because the x squared plus 1 in the denominator. So that term will never become 0. So in this case, no vertical control. Limit of y as approaching infinity, and then we take the limit of y as x approaching minus infinity. So when you take the limit of both here, then you get a number x equals 3. So now let me ask you this. If we now have this here, if the limit stops, if this limit of y comes out to be 3, then what is it asking for? Can you now make the conclusion? If this limit is equal to 3, the conclusion is what is it asking for? Can you make a conclusion? If this limit right here comes out to be 3, right here, 3, conclusion is what is it asking for? I look at the equation right there, which we just proved. This guy here is equal to 3. That means that what is it asking for? Can somebody tell me? The limit of y as x approaching infinity is equal to 3. So that means what is it asking for?
Y equal to 3.
That's right. That means the conclusion is y equals 3 is equal to y equals 3 is an asymptote. According to the definition of asymptote. According to definition 1, according to definition of horizontal asymptote. Okay? So make sure that you understand what's going on here. You have to know the definition really well. So according to the definition of a horizontal asymptote, I think this was definition number 2. Definition of horizontal asymptote. The number 1 definition is the definition of vertical asymptote. Number 2 definition of horizontal asymptote. Number 3 definition of slant asymptote. And definition 3 prime, that's asymptotic. Definition of asymptotic. That number 3 prime is actually an asymptote, which is a curve. A curve asymptote, if you will. It's a curve, not a line. If the curve is approaching another curve, then we say that the two curves are asymptotic to each other. So the asymptotic 3 prime is not a line, but it's actually a curve. So sometimes we can call that a curve asymptote, or we officially use the term asymptotic because it is not a line. Now if you look at the left is what do we have on the left side. So limit of y as x equals to minus infinity. And if you compare the two here, the key point is that the difference is this. I want you to study this here. Again, I want you to study this. Down to 7, study. Okay, because in this case, if you look at this, 1 over x right here is actually equal to what? 1 over square root of 1 over x squared. This is good. But if you look at the left-hand side, where x goes to minus infinity meaning that means x is less than 0. When x is less than 0, the weird thing happens. This is 1 over x here. And this 1 over x here is now becomes what? Becomes minus at this point. And sometimes this guy is called, we have a name for this. Sometimes this is called a mysterious minus. Sometimes this is called a mysterious minus. Why?
Can you clean up the stuff so I can vacuum later?
So 1 over x is equal
Why do you say it like that?
square root of a minus square of x squared.
Okay.
So basically it's this. Let me show you what I mean. X is equal to what's this? Square root of x squared. When what? When x is positive or 0. This is actually minus square root of x squared. When what? When x is less than 0. So what we're trying to say is this x right here, and this x right here is actually equal to minus the square root of x squared when x is less than 0. Okay? This is actually related to the absolute value. By the way, square of absolute value, the square of x squared is actually the same as absolute value of x. In case you didn't know. Okay? right side adapts the value, the minus adapts the value. Anyway, I'm going to save this. Please study here. I've made all the definitions of everything. So, and then our example, let me see. Oh yeah, what class is called? Wait a minute, 8 or 7? Oh yeah, 7. Example 7 is here. I just did it. And then example 8, we have another one right there. X equals. But you know what I want you to do? I want you to study this example as well. So what I'm going to do is I'm going to ask you to study this example 7. Okay? Study example 8. Study this one.